The internet demystified. Forget the cloud. The internet is a massive, tangible, global machine of cables, light pulses, and strict mathematical protocols. Let's look under the hood. 1. The physical web. Data has weight. It travels through glass and copper. The internet relies on millions of miles of physical cables. When you connect via Wi-Fi, your data travels wirelessly for only a few feet before hitting a router, which pushes it into a physical wire. Submarine fiber optics. Over 99% of international data travels through cables lying on the ocean floor. These cables use lasers to shoot pulses of light through strands of glass thinner than a human hair, utilizing a physics principle called total internal reflection, the ISP hierarchy. Tier 1 networks, the global backbone. Massive companies that own the transoceanic cables. They don't pay for internet, they share access with each other. Tier 2 networks, regional providers that buy access from Tier 1. Tier 3 networks, your local ISP, Comcast Spectrum. They run the last mile of copper or fiber to your home modem. 2. Protocols and packets. How billions of different devices speak the exact same language. The anatomy of a packet. Files aren't sent whole. A 5 megabyte photo is shredded into thousands of tiny chunks called packets, usually around 1,500 bytes each. Every packet acts like an envelope with 3 parts. 1. Header contains the source IP, destination IP, and the sequence number, so the receiver knows how to reassemble the pieces. 2. Payload, the actual data. A few bytes of your email, YouTube video, or text message. 3. Trailer, contains a checksum, mathematics that allows the receiver to verify if the packet was corrupted during transit. TCP, transmission control, the reliable delivery method. TCP requires a digital handshake before sending. If a packet gets lost, TCP demands the sender retransmit it. It ensures data is perfect. Used for web browsing, HTTP, emails, file downloads. You wouldn't want an image missing a chunk of pixels. UDP, user datagram. The fire and forget method. UDP blasts packets at the receiver as fast as possible. It does not check if they arrived or resend lost data. Used for live streaming, Zoom calls, multiplayer gaming. Speed is more important than perfection. A dropped video frame is ignored. 3. Routing, BGP. The postal service of the internet, mapping the fastest route dynamically. Autonomous systems, ASNs. The internet is a network of networks. These massive subnetworks, owned by ISPs, Google, Amazon, are called autonomous systems. Each has a unique ASN. For example, Google is AS15169, BGP, Border Gateway Protocol. How does a packet get from Tokyo to New York? Routers use BGP. BGP doesn't just look for a path, it looks for the best path based on cost, speed, and network congestion. Because BGP is dynamic, packet number 1 of an image might travel through Canada, while packet number 2 might be routed through Mexico if a cable suddenly goes down. 4. DNS, Domain Name System. Translating human language into machine mathematics. Computers locate each other using IP addresses like 104.244.42.1. Because humans can't remember thousands of numbers, we created domain names. DNS translates them. The 4-step resolution, recursive resolver. Your browser asks your ISP's resolver for an IP. If it doesn't know, it starts the hunt. Root server. The resolver asks the root server, whohandles.com. TLD server. The top-level domain server says, ihandle.com. Go ask specific server. Authoritative name server. Own server replies with the exact IP address. DNS caching. To speed this up, answers are cached, saved locally. Before hitting the internet, your computer checks browser cache to operating system, cache to local router cache. 5. Security, HTTPS and TLS. Protecting data as it passes through untrusted routers, the TLS handshake. Because your packets pass through dozens of routers owned by different companies, anyone could intercept them. HTTPS uses TLS, transport layer security, to encrypt the payload. Here is how a secure connection is forged in milliseconds. 1. Asymmetric encryption, the setup. The server has a public key given to everyone and a private key kept secret. Anyone can encrypt a message with the public key, but only the private key can decrypt it. 2. The handshake. Your computer uses the server's public key to encrypt a newly generated randomized session key. It sends this to the server. 3. Decryption. The server uses its private key to unlock the message and retrieve the session key. 4. Symmetric encryption, the traffic. Both computers now share a secret session key. They use this single key to rapidly encrypt and decrypt all further communication. If a router intercepts it, all they see is mathematical gibberish. GlobNet architecture. The internet isn't magic, it's the greatest engineering achievement in human history.